Last thing I want to teach you is accessing data which is not in files. So let's learn about the virtual file system. When GDAL was built, it was designed for files. GDAL expects your input to be a file, your output to be a file. And as long as you have files, GDAL is happy. It says, I'll take any file in any format that I like. I can write a file in any format that I like. Now, over time, what happened is, well, your input may not come from a file. It may come from different places. Maybe it's a file on a network. It's a file on the internet. How to describe a file on the internet? Right? Nowadays, everybody wants to use files that are on the cloud storage. How do you point to a file on the cloud storage? So many times you get a zip file. So how to describe a file inside a zip file? I have a zip archive. Inside of that, I have one file that I want to use. So GDAL invented this system called virtual file systems. GDAL is able to now read data that is inside of an archive. So you have a huge zip file. You don't have to unzip it to read the data. You can say inside a zip file, I have a folder, inside it there's a file. I want to use this and convert to a call. GDAL can go and find it directly from the zip file without unzipping it. So you can describe the data inside of an archive or files on network or commercial cloud storage. Let's see how that works. The general idea is you have this prefix which start from VSI. So you have different VSI prefix. You'll have to describe your path using the VSI prefix. And the prefix will depend on where the file is. If your file is, you have a diff file inside of a file called my.zip, and you want to do something, you can say gdalinfo/vsizip/myzip/my.diff. And this will allow you to just get info on the file inside of zip. Super helpful that you can now read data from the zip files. You can also read data from internet. So we have the network-based file system. VSI curl is what is used to get information on data that is on the internet. So if you have any data in some URL, say here's some data at this URL. You can prefix it with VSI curl and GDAL can just read that. Let me show you how to use this. In your course material, we have some supplement. Here we have some section on working with KML files. I have this one file here at this URL, https://developers.google.com KML documentation kml-samples.kml. I have this KML file. I want to do something with it, but this is on the internet. So one option would be I will download it to my system and use it, or I can say ogrinfo/VSI curl and then the URL. So let's run this on our system. And OGI was able to open it and showed me all the layers inside of the KML without downloading it. And this works for all files, raster files, vector files, prefix with VSI curl, and you can read the data from any of the network file storage. Super helpful. It works for output as well. If you want to write an output somewhere, you can say VSI curl and describe that, and it'll go to output that if you have the access to that. Another way that you can use this is to access data from cloud storage bucket. So let's say we have the data on some Google Cloud Storage bucket, and I want to do something with that file. GDAL can read data from all the popular cloud storage systems. So we have VSI.GS can read Google Cloud Storage files. You have equivalent for VSI.AZ, Azure files. So if your data is in Azure storage, you can use VSI.AZ. You have similar for S3 and so on. We have another tool in GDAL where you can query a raster for a particular lat long. Let's say you have this very big raster. You want to know what is the pixel value of this band at this lat long. Might be helpful for kind of doing sampling. Say I'm building a web app or I'm trying to extract the value at each point. I have a list of points. I want to extract the value with that. So GDAL has this tool called GDAL location info, where you can give a lat long and a raster, and you can extract the value. We can use this and say, I have this 8 GB raster on the internet. It's a cog. I want to know what is the value at a particular pixel. And I can use GDAL location info and say, I have my file, VSI.GS. This is my Google Cloud Storage bucket. This is the folder names, and this is the TIFF file. This is how you describe a path. this says to GDAL that go look at this bucket, spatial class public data. Inside this folder, you have this file. This is a call, so I'm able to query this dynamically. I don't have to download the entire file. And say at this lat long, 75, 77.5946, give me the value. I need to set this to say this is a public bucket. I don't need to configure the value. So let's run this. And now it's going to the internet, finding that bucket, finding the pixel value, and say at this lat long, the value of this raster is 31. It took less than a second. So again, Cog enables this. You have GDAL tools which can go and find stuff on the buckets or on the internet and use this using this VSI prefix. Super cool. In the old way of doing things, this was impossible. You have to download the whole thing and do this. You can also put this in a file and say, I have a list of locations, 100 points, run this, and you'll get output as structured data. And so these are 100 points, these are the values there. You can extract that. So this is your point sampling tool in GDAL, just using command lines.